Right, welcome everyone. This is now session 3. So today we're going to create the new wall type for the extension, and we're then going to draw the extension, and you're then going to also add the new walls to the existing building. What I thought I would do is, for the wall type for the extension, you're going to create a new wall type. But what I'd like to do is just spend a bit of time and just explain what that wall type or wall system is, so you understand what you are creating in Revit. Because when you create a wall type, ultimately the wall type is made up of layers, and I guess each layer represents a different wall material and a wall thickness, and each part of the wall performs a different function. So, for instance, in the single timber frame 90 wall type, it just contains one layer, which is 90mm, and that, I guess the intention of that, because it's timber frame, its purpose is structural. So the thing is that when you develop a wall type within Revit, you then specify what function the wall will play, and ultimately assign a material to it and a thickness as well. So that becomes a wall system. So the wall system that we're going to use is basically this, and it's based on an insulation product called Kingspan. Now it might be useful if everyone looks at this, okay? So you understand what you're working with. So the wall systems, the wall insulation product is Kingspan. Now Kingspan put out CAD drawings to, I guess, show how their product is used inside a wall system. Now in your case, or our case, the wall system, the overall thickness is going to be 156. So the thing is, we start off with it with a timber frame wall type. We start off with a 90mm stud wall. Now I don't know how good your construction and product knowledge is at the moment. Are you doing units or subjects that are teaching you construction and products and materials? So you have some idea?
Yep.
Okay. The thing is that to be able to draw and document buildings, you need to know how they're constructed and what materials are used. Very important. So if you've got that underpinning knowledge, then so long as you know how to draw, then the drawing process should be relatively simple. So this wall type starts off with a 90mm stud wall. On the inside we have plasterboard. And how thick is plasterboard generally?
15 or 10mm actually.
10mm.
Yeah.
Generally 10. Yeah. Okay. So the common name for plasterboard?
Gyprock.
Gyprock. Okay, the Americans call it drywall. You've ever watched an American show?
Yeah.
So that's on the inside. Now the thing is that when we build a wall type in Revit, we don't include the interior lining. Okay. But this will show you, this is a cross section of the wall type that we're about to develop. Now, in here, this, so I'll zoom in there. So this part here, which is 25mm, is known as a vertical counterbatten. So another name for it is a top hat. So it's actually screwed against the timber frame, and it then supports the cladding, and in between the cladding and the counterbatten is the rigid insulation. Okay, so we've got the top hat, or the counterbatten at 25, we've got the insulation at 25, and we've got the cladding at 16. So that's S-rib or corrugated iron, generally colour bond. So everyone knows what corrugated iron is. Yep. Now, I guess, does anyone know what a top hat is, or know what a top hat looks like, or what its function is? What's it made of?
Steel.
Steel. So, if we're talking top hats, this is what we're sort of, I guess, this is what we're sort of looking at, something like this. If I can zoom in. So typically, that's a top hat profile, a top hat product. So again, that is attached or secured, screwed against the timber frame. So they can either run vertically or horizontally. And I guess it really depends on which way you're going to run your cladding or corrugated iron. So I guess the thing is, if you're going to assign a material to the top hat layer, you probably want some sort of metal as a material. The rigid insulation is this product here, which is the Cooltherm K12. So the thing is that, and this brochure here shows you, typical applications. The thing is that it has a very good thermal rating, thermal performance. I'm not sure of the exact figures, but the thing is that you'll note that inside the wall here, between the studs, we also have airspace. Now, you could conceivably fill that airspace with regular type bats, insulation bats, pink bats as well. So you have that added performance. So again, just some varying ways of using the insulation. And I guess this type of insulation is, could conceivably used in roofs as well. Not generally residential, but so here we have the insulation being used with products like weatherboard, siding, brick. So brick on the outside, brick veneer. So it just adds another degree or another measure of insulation for, to enhance the thermal properties of that wall system. So that's what we're using in our wall system for our extension. Now, I guess to show you how it looks in a 3D sense, all put together, that's what we're looking at. So you can see you've got the timber frame here, you've got the top hat, the counterbatten running through, and you've got the yellow part there is the insulation, and then attached on the outside you've got the corrugated iron. So does that give you a better idea of what we're about to create and use as a wall system? And of course on the inside we've got the plasterboard. So if we return back to our projects, now one of the last things we did in our last session was to import the AutoCAD drawing, put it into position, and we turned off some of the layers contained within the drawing. Now, did we leave the rainwater tanks turned on? Or did we turn them off? If they're still visible, can I get you just to turn them off, please? Just the rainwater tanks. So that we're just left with the walls in blue. And if you're not on Learn yet, you can just log into Learn, go to part 1, just open up the assessment task document here. Now we're working on page 9 from part 6, new construction. We've brought in the AutoCAD drawing and we're about to work through part 6.3, which is creating the new wall type. Now note the name of the wall type is this, Custom Orban Insulation 156, and we're going to start with a wall type of stud timber 90, so that's our starting point, and we're going to make a copy of that and then make modifications to the copy, and of course rename it to this. Now the way we're going to create the wall type is within the project browser. I'll just bring that out here so you can see it. Now, whenever I'm creating a new type of anything, and it could be walls, it could be doors, it could be windows, I do it within the project browser. So if I'm creating a wall, I don't start the wall command or tool and then create the wall type. I actually do it before I get into the wall tool. Same with doors and windows. So the way this works is that within the project browser, you've got a branch down here called Families, which I think we have looked at before, haven't we? Anyone out there? Yeah. Okay. So, and if you expand walls, we're working with basic walls. So if you expand basic wall, you'll find or see stud timber 90. Now to create the wall type that we need, all I simply do is double click on stud timber 90, which opens up the type properties of this wall type, and then from there duplicate, and then type in the name of the new wall type. I've done a copy and paste, and click OK. So in setting up the new wall type, we go into its structure by clicking Edit. And here you'll see that within the wall type, as I said earlier, we have a column here for function, one for material and one for thickness. So, and what we have to do is, if I go back to the document here, on page 11, we're going to add 3 new layers. So one will be finish 1, which is metal deck, will be the corrugated iron. Layer 2 will be the cool therm rigid insulation. And layer 3 is the top hat, okay, the counterbatten. So, and each has a different function. So typically, if you're putting a cladding on a wall type, or if there's a cladding there, the function of the cladding becomes finish 1. If it was actually plasterboard on the inside, you would actually assign a function of finish 2. So finish 2 on the inside, finish 1 on the outside. The insulation is considered thermal or an air layer, and the counterbatten is a support system, so that becomes a substrate. Okay. So note the materials assigned and note the relative thicknesses. So to set this up in Revit, what I've done is I've highlighted layer 1, the current layer 1. Down here, see the insert button? So basically just click that 3 times to create 3 new layers. So it's important that the 3 new layers sit above this core boundary, and that the timber, which is the structure, so that see how the timber has a function of structure assigned to it. So this timber must sit between this core boundary and this core boundary. So we then just click over here. I would go through and just change the function. So substrate, thermal, finish 1. You could then perhaps go over and assign the thickness, so 16, 25 and 25, and then just go through and add the materials. So in adding the material, if you actually just click over here, it will open up the material browser. And you can, in fact, up here in the search box, you can, I'll just bring that down, in the search box you can actually just type in the full name of the material, and it will appear here in the search. Even if you type in the first word, generally the material comes up that you're looking for. And then finally, metal stud layer. Okay, so once you've done all that, you can OK that to exit the structure, and then click OK and the wall type is then produced. So we're going to, now that we've created the new wall type, we'll actually add these the walls to the extension. We'll do those last. What I'd like to do now is we'll just have a look at putting in the 90mm stud walls in here into the existing part first. Now you'll notice that there's a couple of very thin blue lines here. Now this is the bathroom. Now these this is actually a shower screen, 10mm thick, and we're going to create a new wall type also for the shower screen as well, and actually add it as a wall. So things like, I mean, the thing is that if you're, if you're using some sort of vertical structure, and it doesn't matter really what it is, you can use a wall to represent that particular item or product. In this case, it's 10mm toughened glass. So what I'm going to get you to do as an exercise is create another new wall type for the shower screen. And I want to see if you can do it yourself. Okay? Now, so I'll just close that. And okay. So the wall type, I'll make that nice and large so you can see it, okay. New wall type, so it's going to be called shower screen. It's going to be 10mm thick. It's going to have a material assigned to it of glass, clear glazing. And when you add the wall, when you actually place the wall, it's going to be 2 metres high. So this is a little test for you to see if you can create this wall type. Now, my only tip here is that when you're creating this wall type, that you actually create it. You start with where are we? Start with the generic 100mm wall. Okay, so that's your starting point. And make a copy of it to create this. Okay, exactly the same way you did with your custom wall type. So that one you started with 90mm stud wall. This one you're going to just start with a generic 100mm. So I'll get you to work on that now. Because as you work with Revit, when you're working on more complex projects, ultimately you're going to have to customise and create a lot of non-standard things. And to create a new wall type is a relatively easy way of creating some sort of vertical structure. So I just want to get you used to actually thinking about how you would create these things and what part of the software you would use to create them. Okay, so that's our shower screen wall type. Now, when you add, we can perhaps, now that we've created the wall type, we can actually perhaps just draw or add the wall now for the shower screen. So we'll do that first. Now, when you're doing this, because this is a very, very thin wall type, it's only 10 mil, perhaps the easiest way of adding this wall would be to select the wall tool. Now, what height did I say it was? 2 metres. So, how do we set this to 2 metres?
In the properties column.
We can do it up here on the options. So at the moment, we'll select the correct wall type. So this is shower screen. At the moment, the height is actually set here as unconnected, which is what we want. So we don't actually want this to go up to the next level. So we leave it unconnected, and we set the unconnected height to 2000. Now, when you're adding walls, because we've actually got the AutoCAD line work here, we can add walls by a process of tracing. Okay, so you can either snap to the AutoCAD line work using 2 points, or you can use this option here, which is pick. Everyone watching? Okay, pick. We would normally draw walls by line, which is 2 points, but we can actually use this option here, which is pick. Now the way pick works is that when you approach the AutoCAD line work, it's a little bit hard to see, but you can see there's a blue dashed line running through between the AutoCAD lines. If I move up, it pushes that dashed line underneath. Okay, so providing the blue dashed line is sitting between the AutoCAD lines, the wall will actually be produced directly on top of the AutoCAD lines. That's using the pick method. And what that does, of course, is it sets the length of the wall exactly as per the AutoCAD lines, using pick. So in some senses it's probably more accurate than actually clicking 2 points. Alright, so in some cases when you're adding your walls, you can actually use the pick method. Okay, so that's the shower screen wall added. So as I said earlier, I'm going to show you how to, I guess, start adding the 90mm stud walls. Now, if you're adding walls inside the existing, note that they are 2.4 metres high, which means that they go to which level? FCL, finished ceiling level, so that's 2.4. What's the other ceiling level we've got? 2.7. And what's the level name? New FCL. Okay, so we've got 2 levels that we're working to. Now, the walls inside the existing building are 2.4. The walls out here, the new ones, are 2.7. The wall that divides the existing and the new, this one here, is 2.7. This one here. The one next to it is 2.4. Okay, so we've got a couple of walls side by side that are different heights. Now, this wall here has these openings in it, but when you draw the wall, you actually draw the wall straight through the openings. the openings are added after the wall is actually drawn. Does that make sense? So, wall, stud timber 90. The height here. So choose your wall type, stud timber 90. Set your wall height, new FCL. Finish face exterior is the location line. And then what we do is we, using the line option, we pick this point here and we draw down, take this wall down to here. And escape. Just escape once. That will keep you in the wall tool. So we've drawn that wall there. So what I would suggest then is to draw this wall and this wall here next. So we then just have to make a quick adjustment to the height. So that becomes FCL. And click here. Then click here. And then go across back to here. And escape. And I would escape again. Now, you'll see where I am here. Now, this little wall here, for some reason it just cuts across halfway. It doesn't actually sort of come down to here. This one here. See the blue AutoCAD line? So we have to bring this wall down so it actually lines up with this AutoCAD line here. So the way we do that is to use the Align tool, select the AutoCAD line, and then select the corresponding side of the wall and just bring that down. Okay, so does that make sense?
Yep.
All right, so we've got this wall here at 2.7. We've got this wall and this little wall here at 2.4. Now I'll just quickly show you, so just moving over here, I'll just show you how to add this wall here and this part wall here, and then you can just continue on adding walls yourself. So this wall here, drawing this wall in here, what I would suggest is, and I guess you decide which method you're going to use, but in most cases you can actually use the pick lines option. Everyone watching? Everyone? Watching. Okay, pick lines. So just check your wall height. So with this one here, again, just make sure, when you're doing this, make sure that the blue dash line is inside the AutoCAD lines when you pick. And you can also do this one as well while you're here. Now, the thing is that this wall will stop here, but it really needs to actually continue to the end of this wall. Okay, it needs to be continuous. So what we can do here is use the Align tool. Okay, pick the end of this wall and then pick the end of this wall and take it down there. Okay. Now, we've got two separate walls. This is a new wall and this is an existing wall. Now, what you need to do, if you have a situation where you've got two walls that are butting up together like this, you then need to, on the Modify tab, you need to use the Join tool here, Join Geometry, which we looked at last Monday, I think it was, in the little exercise we did. So join that wall with that wall, and the walls are still separate, but they appear seamless. And it's important to do that because when you add the sliding door in the next stage, if you don't join the walls, the sliding door won't go in properly. Okay, so that's important. So once that part wall is in, so that's that part, you can then add this part in here. Now, doing this part here, you're going to have to use the line tool. So you're actually going to click 2 points. So first point and second point. Okay. Now that will cause an overlap. Okay. So again, what you'll need to do with the wall you've just added, note the bubble here, little circle here, drag wall end. So you drag that wall down to there, select the wall, and then you right click on the bubble. Okay, right mouse click on the bubble and choose Disallow Join. Okay, everyone watching, this is quite important. Disallow Join. There will be other occasions where you'll have to use this technique to sort out wall joints, particularly where you've got three walls coming in to the same point. Okay. When the wall end is disallowed from joining, you get the little T symbol. Once you've done that, you then go to Modify, Align, select this wall as the reference, and then take this one up to it, and you won't get the overlapping. Okay. Now you will still have to use the Join tool to join that wall with that wall. Alright? And then that takes care of that entire length of wall. Okay? The rest of it is very straightforward. Okay? So just continue tracing the blue walls here with your 90mm stud. And then we'll have a look at the new section here. You've also got in the new section here. You can add these walls now if you want to, or do them after you've added the external walls. But these are stud timber 90, but they go up to 2.7. So this is the walls that surround the heater as a feature wall. So again, I try and use the pick lines option where I can. It's just a lot quicker. Alright, so I think we've all now put in the filled in the gaps with the new walls of the existing. So let's just quickly trace around and add the new walls here for the extension. Now, my recommendation here is, so when we start the wall tool, select the correct wall type. Make sure it's set to new FCL. Finish face exterior. Now, my recommendation here is to start down here. Okay, see where I'm starting down here? Now, my recommendation is not to start here. Okay, everyone watching? Don't start here, but just start back here. Okay, just away from the wall junction. Okay, start back here, and then I'm just going to trace by selecting points, the corners of the AutoCAD walls. Okay, so again, when you're doing this, please ignore doors and windows, just draw straight through them. Okay, when you get to this point here, stop short. Don't go all the way. Stop at about here. Okay, so I've got a gap here, and I've got a gap down here. Now I'll come back to the start. Now the thing is that if I had started the wall over here, the walls here, this wall here would attempt to join with this wall here, and you'll get you can get the results are it's really sort of unexpected. It can be quite messy when the walls try to join automatically. So exit the wall command or tool, select this wall, and right mouse click on the button here and say disallow join. Okay. Now when you use the align tool, select the end of this wall as the reference, and then take this wall to it. Okay, so in this area here, your walls are joining cleanly. They're not trying to automatically join, and that's what the disallow join will allow you to do. Okay, you control how your walls are joining. So same up here. Select the wall, right mouse click and disallow join, and then using the align tool, this is your reference, and then you're taking the wall to it. Okay, so that's what you need to achieve in that area there. So if I turn on shading, that's how it should behave. So just go back to hidden line, and we've put the walls in here, so that now is all the required new construction as far as walls are concerned. So, for instance, if we now go back to our existing floor plan, again, there should be no modification to the existing floor plan. As I say, apart from a couple of walls or 3 walls at least, that have splits through them. But if you've done this correctly, then the existing plan should be unchanged. The demolition plan, again, same thing. It looks like that. So you might want to just do a couple of quick checks to make sure that your existing and your demolition plans look as they should. So the next stage now is we're going to have a look at adding the doors and windows. So we're about to go to a break. After the break, we'll have a look at doors and windows. Right, so we're going to have a look at placing the doors and windows now. So if I just jump back to Learn, looking at the assessment document. So in section 6.4, one of the first things you'll do is change the visual style of the floor plan to wireframe, so that you can actually see the AutoCAD doors and windows, because as you note, I mean, you can see this one here, but that's about all. You might be able to see little bits of doors and windows either side of the walls, but to actually see the AutoCAD outlines, you need to set the visual style of this particular floor plan to wireframe. So what does that mean? Set the visual style, change the visual style. Where do we do it? What's that part called? What are those controls? What do they do collectively? Change some aspect of the view. So they're known as view controls, hence view control bar. So the visual style is this one here, the cube, and the top. So what visual style is default in every view? Anyone know?
Hidden line.
Is it hidden line? Yeah, it is hidden line. Okay, so if you don't change it, the default visual style is hidden line. Now we're going to change it to wireframe. So it just makes everything completely see-through. So we can now see the AutoCAD doors and windows. Now, if I go back to the document here, so add all required doors and windows to the existing building and extension. On Learn, you're going to refer to this document here for the correct placement, and also to identify what the doors and windows are and their sizes. Now, there will be some loading of doors and windows required. Okay, some of the doors and windows are actually part of the file, the Revit project. Some you'll have to load in either from the standard Revit libraries or from families that you download from Learn. So, for instance, there's a product called Breezeway, and there's a couple of window families that you'll require for louver windows in the project from a company called Breezeway. Now I've provided you with the families and they're all set up, ready to go. you just need to download them into your families folder. So that was the folder you set up on Thursday in our last session. So you download them into that folder first, and then you load them in to the project. So there are a couple of breezeway window families. I think from memory, you don't have to load any other window families in. You may have to load in a door family, and the rest are inside the project. So what I would do is perhaps start by locating these window families on Learn, download them, and then bring them into the project. That's the starting point.
Sorry.
So if I go back to Learn under Part 1, just scrolling down under Doors and Windows here, you've got, this is the document that it refers to for location, size and type. So I'll come back to this. These are the two breezeway window families that you'll need to download. So you might start by downloading those two. Okay, so they're going to go into the families and groups folder. So they'll sit there, waiting for you to load them into your project. Now, if we just come back to this sheet here. So, on the sheet for doors and windows, you'll see that each new door and window is noted. So each one has a number assigned to it. So if we're looking at, we start with windows for instance. So you'll see window number 1 is a DC breezeway multi-bay 102 glass. The information down here, you don't have to change, you don't have to modify the breezeway families. They are all set up correctly. You just need to place them. You do not need to make any changes to them.
It wasn't.
The breezeway windows are divided into two types. There's a multi-bay and a single bay. The multi-bay, there are two types within the multi-bay. Okay, there's a one that has a height of 438 and another one that is full height. So you do not need to change any of the settings within the breezeway window families. Just use them. Once they're placed, you'll just need to set the head heights. And if you have a look over here at the table, what I've done is I've put in a table here that lists the window numbers. So you'll see that window number 1 is a 2-bay breezeway. And essentially this table just gives you the head height. Okay, so this is just indicating the head height of all windows. Over here it will tell you the family and type. So again, with the breezeways, you just place them, you don't have to create them or adjust them. When you come to, say, window 2, for instance, this is a family called M-Fix, which the M-Fix family exists in the project. Now, you will have to actually duplicate and create at least 2 types or 3 types of M-Fixed. So you'll have to go through and set up the type, change the height and width before you place them. The sliding door 2 panel, there is one already in the project, so you'll need to just duplicate and create a new type there. So for this door here, single glass one, that is not in the project. You'll actually have to load that one in yourself. So that you'll find amongst the standard libraries. And of course you'll have to load in the opening dash door family and create 2 types there. Now, how from memory, and you've done this previously, with the opening dash door, how do you actually place it in the project, in the model? It's a component.
Yeah.
It's not a door, it's a component. Okay? So, when it comes time to placing these, you'll know what to do. Alright? So you won't actually say, I'm clicking door, but I can't find this opening door. Alright? So you won't ask me that. You'll actually know to place it as a component. A note, Windows 8 and 9. So you've got a single breezeway window, which is the lower, I think, from memory. Yeah. So Windows 8 and 9. If we have a look over here, so you've got 8 is the lower one, and 9 is the upper one. So it might be that you actually put in the breezeway first and then place the upper window after that. Now the thing is that don't forget that you don't have to place windows in a plan view. You can put them in through an elevation. Alright, so if that's easier, that's what you do. So in this case, if you have to put one on top of the other, put one in first, and align it in your floor plan, and then place the second one in your elevation and line it up in your elevation. Okay, use the align tool in your elevation to align the top one with the lower one. Okay, because sometimes it's impossible to do that in a plan view. Now, window number 3, which is this one over here. Window number 3, what you'll do is you'll leave that one to the very last. And window number 3, you'll actually place in the north elevation. And it will initially sit a little bit higher than the wall, okay, when it's actually at correct height. Note that the spacing or the measurement here, 9-10. So the thing is that when you're placing the windows and doors, what I would suggest you do is place the when it comes to windows, place the window into the wall first, align it with the AutoCAD line work, and then immediately set the head height of it, and then move on to the next one. So now, just something that I've discovered with Revit, with 2018, if for instance, so when you bring your families in, you'll go insert and you'll go load family. And normally, Revit will actually look at the default libraries. What you're going to do is you're actually going to browse for, initially, for those two breezeway families. So you're going to browse and you can probably bring them both in at the same time by click and control click. So they'll go through an upgrade process because they were produced in 2017. Okay, so they're in. So the thing is that, again, when you're loading families in, these are windows, don't sort of click window first and then go load family, or door and then load them in. Just load them in without being in any command, just through the insert load family. Once they're in, so this one here, for instance, we go back to our sheet. So this is window 1. So this is a DC breezeway multi-bay. Now it's a 2-bay, and the height is 2148. So we go to architecture, window, and in the type selector, notice the multi-bay, you've got a 2-bay and a 5-bay. Okay, so in your project, you're actually going to place a 2-bay in two locations and a 5-bay in 2 locations. So 2 of each. So the 2-bay, so we come over to the wall. Takes a little while. So there it is there. So just get in nice and close, and just when it appears. Now, when you're using these breezeways, it's important that you actually get them in the right orientation. As I said in my instructions, make sure they're not inside out. And the important thing is to put them in so the louvers are pointing downwards on the outside. So just place the window close to where it needs to go, so about there. Just escape from the Windows tool, okay, and then use your Align tool by picking an AutoCAD line as the reference, and then the corresponding line on the Revit window, and then bring the Revit window to the AutoCAD line work. Now, when you reselect the window, I'll get you to do 2 things. One is to set the head height. Okay, head height over here. So this one needs to be 2148. And the other thing I'll get you to do is actually change the mark, which is the number of the window. Okay, so this is window number 1. So you change the mark to 1 as well. And when it's in position, place a pin in it. Okay, so pin it. So if we have a look at that window in our 3D view, here it is here. Now, what I would suggest you do is, at some point, open up your 3D view and change your phase filter in your 3D view to show complete. Okay, does that make sense? So phase filter down here in your 3D view, show complete. So that's the window I've just placed. Okay, so I don't really think there's anything else I need to tell you. You've got, in this area here, you've got a series of sliding doors, which are already preloaded into the project. You just need to work out which size to use and just add them into the locations. So again, just place them close to where they need to go and use the align tool to actually lock them into the exact position. And each time you place a door and window, or particularly the windows I should say, just change the mark or the number, and then pin them in place. Now with the door numbering, with the doors, go back to learn, and we're probably getting a little bit ahead of ourselves, but with the don't worry about the door numbers at this stage. Just to do the window numbers, we'll worry about the door numbers later. So, all right. So, if there are no questions on that, I'll just get you to work through adding the doors and windows. Yes, something that comes up, something that I mentioned earlier with Revit 2018 is that when you load in a family and you then go off and browse and go to your own folder, for instance, or another location other than the standard families, when you click Insert Load Family again, it remembers where you've been. So it doesn't automatically snap back to the default Revit libraries. So what I've discovered with Revit 2018, over here, see you've got links through here. If you scroll down, there's a couple at the end. There's Metric Library and there's Metric Detail Library. So if you want to get back to your standard libraries, click this button here, and it takes you back. Okay, so yeah, I thought up until now, I know where the libraries are on my local machine, but here at TAFE, the libraries are on a network drive. So really, if you don't have this link, there's no way of finding them again unless you restart the software. And I really only discovered this last night when I was just working through the exercise, that you can get back by using these shortcuts. Okay. All right. So I've now added all the doors and windows. Now, just a couple of things. I said earlier, or spoke earlier about window number 3. Okay, so window number 3, you will place in the north elevation, that's this one here. So its head height, so window number 3, its head height is 2860. Now the 2860 is from finished floor level. Okay, so when you place it in the wall, when you place it in the wall, initially just unpin it. So initially when you place it in the wall, it might actually come in at level FCL, okay? FCL. So, and the head height might be something like 400 something. Now, what you need to do is select the window, change the level to FFL, and then change the head height to 2860, and then it will be at the correct height. Okay? What I would suggest you do with the north elevation is just change the detail level, because initially it will look like this. Change the detail level to medium, and just make sure that the window is 910 from the end of the wall here. Okay, so that's now correct, and it will sit slightly above the wall initially. Now with the two windows, with the two windows 8 and 9 in the south elevation here, so the louver goes down here and the fixed up here. Now again, I'm going to change the detail level. Detail level is medium. Just that. So this the louver window is in the correct position and at the correct head height. The fixed window is the correct head height, but it's slightly off. So what I was saying is just place the fixed window in this elevation, roughly in where it needs to go. Set the head height, and then using your align tool, align this window to this window. So using that as your reference, align there. So that the two of them are lined up like that. Okay, so providing they're lined up that way vertically and they're at their correct head height, and again they need to be measuring, or the head height needs to be measured from FFL. They will be directly on top of each other. Okay. So again, we have a look at the 3D. We've now got all of our doors and windows in place, and we're then, or will be ready to sort of move on and make the cut in the roof in this area here. And then once we then cut the roof, and then we make modifications. We cut through the, well, when I say cut, we actually remove sections of the fascia, the gutter, the eave lining, and we make some modifications to the roof framing. Okay, so that's going to be in our next session. So for today, if you can just ensure that you get all your doors and windows in place, and then we'll do the roof modification next session. Alright, so unless there's any other questions, I mean, we've got sort of just over 10 minutes left of today's session, so I'll just get you to continue working with your doors and windows. Unless there's any questions, I'll sign off today with the recording, and we'll pick this up in our next session.